Good evening students, welcome to basic electrical lectures. So we are doing a module 4 lectures. So it is class number 4. So in this lecture I am going to explain derive EMF equation of DC generator. So it is very important derivations in the DC generator topic. Only one derivation in the syllabus for DC generator. And in motor we have another derivation that is called derived torque equation of DC motor. So in the entire module 4 we have only two derivations, derived EMF equation of generator and derived torque equation of motor. Out of these two they will ask alternatively in previous year question papers. Okay, if this year they asked torque equation, previous year they might have asked EMF equation of generator. So we cannot predict, they can ask same question again also. Okay, whatever the question asked in last time, they can ask this time also, same thing. All possibilities are there, but keep in mind, don't stick out to the question papers. You just complete the syllabus. If you complete the syllabus, 100% you will get full marks, 20 out of 20 in each modules. Don't think about question papers. Once module is completed, then you refer the question papers and try to solve those questions. Okay, that is the correct way of preparation. So we can start. Derive an EMF equation of DC generator. So before deriving this, we have to write usual notations. Okay, let capital P is number of poles and capital Z is total number of conductors are connected in series. Total number of conductors are connected in series, and pi is equal to flux per pole in Webers. Capital A equals number of parallel paths. Okay. So this number of parallel path depends on type of armature winding. Armature winding, basically we have two types, lap winding and wave winding. So if it is lap winding, you have to consider number of parallel path is equal to number of poles. If it is a 4-pole machine, then how many parallel path will be there? 4 parallel path. Similarly, for wave winding, we have to consider number of parallel path is equal to 2 only. Number of parallel path for wave winding, you have to write A equals to 2 only. And another notation, capital N. What you should write? N is nothing but speed of armature in RPM. Speed of armature in rotations per minute, RPM. So these are the usual notations required to derive EMF equation of DC generator. See, we know that what is the working principle of generator? Generator works on the principle of Faraday's law of electromagnetic induction, that is dynamically induced EMF. What it states, whenever a conductor cuts the magnetic field, an EMF will be induced in it due to relative motion between conductor and magnetic field. The direction of induced EMF is determined by Fleming's right hand rule. That is what we learned in generator working principle. So refer lecture number 1 or 2. So let's look at here now. Now according to, I have dictated this, you just copy down along with me. Now according to, please write, according to Faraday's law of electromagnetic induction, the average EMF induced in a conductor is given by, the average EMF is induced in a conductor is given by EAV is equal to d pi by dt. So take this equation number 1. According to Faraday's law of electromagnetic induction, the average EMF induced in a conductor is given by EAV equals to d pi by dt. What is d pi? Change in flux. Very good. What is dt? Okay, time taken to change the flux. The rate of change of flux will give results to an EMF, induced in the conductor. Okay, so that we can collect it by the brushes and we can feed that induced voltage to the external circuit. So now consider, again write this statement also. Consider the conductor rotates 1 revolution. Consider the conductor rotates 1 revolution. Okay. So due to that the change in flux becomes, due to that the change in flux becomes flux cutted by all the poles. Due to that, the change in flux becomes flux cutted by all the poles. That is, you write down d pi can be written as pi into p. The change in flux can be written as flux cutted by all the poles. Now I will give reason for this. Don't write what reason I am giving in your notebook. Just write this one. That is sufficient. But understanding is important. Why I have written pi into p? For that I will give explanation here. See, so conductor. This is a conductor, rotates. Okay. So north pole, south pole. Don't write. Simply observe what I am explaining. So between the poles, there will be lines of flux. Between the poles, there will be lines of flux. Okay. See now, the conductor is rotating. How it is rotating? What it is? Generator. What is required for input to generator? Mechanical is the input to the generator. What is output? Electrical. So, due to some mechanical input, the conductor rotates. Whenever conductor rotates, this conductor going to cut the flux. Produced by all the poles. Okay. Whatever the flux produced by this pole pair, this pole pair, this pole pair. So that conductor rotates, it is going to cut flux produced by all the poles. That is why we are writing d pi is equal to pi into p. Whenever conductor rotates one revolution, okay, the flux is cutted by all the poles. That is nothing but change in flux. The change in flux is due to flux cutted by all the poles. So, and along with this, and the conductor is rotating, you have to determine what's the time taken to complete one rotation. Okay, and the time taken to complete one rotation, continue, and the time taken to complete one rotation is given by dt is equal to 60 by n. The time taken to complete one rotation is given by 60 by n seconds. Now substitute d pi and dt value in equation 1. After substituting, so we can write average EMF induced in a conductor, EAV is equal to pi p divided by 60 by n. So next step will be EAV is equal to pi p n by 60. So this will be equation number 2, and it is called EMF induced, average EMF induced in one conductor. Okay, in one conductor this much voltage will be induced. Okay, so if it is 40 conductors, multiply by 40 conductors, then what you will get? Total generated voltage. So you cannot write directly into number of conductors. Okay, because the armature winding will be either lap connected or wave connected. So based on that, we have to multiply number of conductors per parallel path for equation 2. That gives a total EMF generated in a machine. We can give reason for that. Okay. So whatever I am explaining now, that also don't write. Okay. After equation 2, I will dictate one sentence, then you copy down what I am saying. Okay. Before that, we need to know the reason why I am multiplying Z by A conductors for equation 2. Okay. Now look at here. Now consider total number of conductors 40. Okay. And number of poles, there are 4 poles. And assume it is lap type of winding. You can take lap or wave. Choice is yours. I will explain both. Okay. See now, if the winding data is not at all specified in the question, under that condition, the Z value given 40 conductors, no, all those conductors will be connected in series when winding data is not given. Okay. So how it will be connected? So first conductor, this is one conductor, second conductor, like this, all 40 conductors will be connected in series. when winding data not at all specified. But in general, winding data will be given. Okay, in practical cases, either the machine will be lap winding or wave winding. Look at here. If it is a lap winding, how many number of parallel path? If it is lap winding, what I give the condition? A is equal to poles. If it is lap winding, A equals to poles. Then all these 40 conductors will be splitted into number of parallel path, equally distributed in all the path. So therefore you should write Z by A conductors. What is Z? 40. What is number of parallel path? A is equal to 4 because lap winding, so 4 poles. How many conductors in one path? 10 conductors per path. Out of 40 conductors, 10 conductor 1, 2, dash 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 till 10th conductor are connected in series. Similarly, another parallel path. Okay, totally how many conductors? 20 conductors. Still remaining 20 is there. So all those conductors will be connected in this way. Okay. Nowadays, how many parallel path? 4 parallel path. Okay. 1, 2, 3 and 4. What is EMF induced in one conductor? The EMF induced in one conductor is how much? Pi Pn by 60. Pi Pn by 60 is EMF induced in one conductor. Multiply by number of conductors comes under in that parallel path. How many conductors according to this data? 10 conductors per path. But in general what you can write? Multiply by number of conductors per parallel path. That gives total EMF generated. See, whatever voltage generated here, same voltage will be there here and here and here. Why? Because all are connected in parallel. So in parallel, whatever voltage between from this point to this point, same voltage will be there in this path also, in this path also, in this path also. Because in parallel, voltage will be same. So again, basics. Understood, guys? So now, in parallel, in lap winding, number of parallel path will be more. So lap winding is suitable for add all this current in each branches. So the total current will be very high. Therefore, lap winding is suitable for higher current, lower voltage applications. Okay, got it? Now, same example. If I take wave winding, then what it will be? So Z is equal to 40 and number of poles is equal to 4 poles. And if it is wave winding, what I should take wave? A value should take 2 only. Here you should take 2. So now how many conductors per path? So 40 by 2. Now 20 conductors I need to connect it in one path and all those conductors should be connected in series. Okay. Why we are connecting in series? In order to get required induced voltage. In order to get required voltage, we have to connect the windings in series. Okay. See. Now only 2 parallel path because wave winding, one parallel path, another parallel path. So now look at here. So some I1 current flows here, some I2 current. See, what is EMF induced in one conductor? Pi Pn by 60. Now what you should write? Multiply by how many conductors in that path? Now 20 conductors. How you can write the 20 conductors? Again, same manner, Z by A conductors. Okay. So therefore, once you multiply it by Z by A conductors, you will get voltage across these 2 points. In this parallel path, you will get a voltage. Same voltage will be there here also because parallel voltage will be same. But in wave winding, number of parallel paths are less. So addition of these 2 currents, then your total current will get reduced. Total current will be only I1 plus I2. Okay. But here, what is the total current here? I1 plus I2 plus I3 plus I4. You will get more current in lap winding, less current in wave winding. What about voltage? See, only 10 conductors are there. So multiply by 10 times. But what is voltage will be here? 20 times 20 conductors are there, you will get more voltage, and here you will get less voltage because only 10 conductors are in series per path. Here 20 conductors are connected in series per path. So therefore, what we can conclude, wave winding used for high voltage, low current applications, and lap winding is used for high current, low voltage applications. Remember, very important. Okay. Next class, in comparison of lap and wave winding, I will going to repeat this point. Okay, understood guys? So therefore, now you can write. Okay, don't write all this. If you are interested, you can write. But it is not required for exam, only for understanding. See, now look at here guys. For equation 2, okay, generally the armature winding consisting of several armature conductors, and the winding may be lap or wave connected. Therefore, for equation 2, multiply by Z by A conductors, which gives total EMF generated. Understood? That thing what I said now, you should write it here. Okay, after equation 2. So pause the video and then copy down. See guys, look at here now. I will dictate once again, you just copy down. After equation 2, write down. Equation 2 is EMF induced in one conductor. After that you write. Generally, the armature winding may be lap connected or wave connected with several number of conductors. With several number of armature conductors are connected in series. Therefore, the total number of conductors per path, therefore the total number of conductors per path within the bracket write down Z by A conductors. Therefore, the total number of conductors per path within the bracket around Z by A should be multiplied for equation 2 to get total EMF generated. To get total EMF generated or induced. To get total EMF generated or induced is given by, see now I am writing capital letter. EG is called total EMF generated. This EF is EMF induced in one conductor. See now we can write EMF induced in one conductor is pi p n by 60A multiplied by Z by A conductors. So this is EMF equation of a DC generator. So in correct way you can write like this, pi p nz by 60A. So both are same, only I cancel into, so just multiply. This is EMF equation of a DC generator. Understood guys? Very simple. See, what you should write in exam is, write the notations according to Faraday's law of electromagnetic induction. Average EMF induced in one conductor is EAV d pi by dt. Consider conductor rotates one revolution. Due to that, flux cutted by all the poles, that is change in flux. Time taken to complete one rotation is 60 by. Substitute d pi dt in this equation. Simplify, you get this one. For equation 2, multiply by Z by A. Simply write that. And finally you write this term. Don't write whatever I explained the concept. So I just given subject knowledge. Okay. So that you can understand, but don't write all in detail in exam. Okay. So let's look at here now. If it is lap winding, okay, if it is lap winding, what is A? A equals to P. Then EMF generated in lap winding is, okay, pi P nz by 60. What is A value? A value becomes what? P. Now poles get cancelled. Therefore, EMF equation, EMF generated if the machine is lap connected is pi nz by 60. Separate equation for lap winding. This is applicable for both lap as well as wave. but this is only for lap winding. What is EMF generated in lap winding? Pi nz by 60, pi nz by 60. Now similarly, if it is wave winding, A equals to 2. So now EMF generated in wave winding will be pi p nz by divided by 60 into what is A value? 2. A value is 2. A value will be 2. Therefore, we can write pi p nz by 120. So this will be separate equation for wave winding. EMF generated in wave winding means pi p nz by 120. Lap winding pi nz by 60. Okay, got it, guys? So this completes, okay, derive the EMF equation of a DC generator. See, you should write before writing this equation, write a sentence. How we got this? And write a sentence, write d pi by dt, then simplify, then finally, generally I explained one sentence after equation 2. Write the sentence, multiply by z by a. That completes the derivation. Don't give reasons z by a in detail. Okay, dear students, pause the video and then copy down. So ನಮ್ಮ ವಿಡಿಯೋಸ್ನೆಲ್ಲ ಲೈಕ್ ಮಾಡಿ, ವಿಡಿಯೋ ಲೆಕ್ಚರ್ಸ್ನ ನಿಮ್ಮ ಸ್ನೇಹಿತರಿಗೆ ಶೇರ್ ಮಾಡಿ. ಸೊ ಇಂಜಿನಿಯರಿಂಗ್ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ ಶೇರ್ ಮಾಡಿ. ದೋಸ್ ವಾಸ್ ಸ್ಟಡಿಂಗ್ ಇನ್ ಪಿ ಸೈಕಲ್ ಅಲ್ಲಿ ಯಾರು ಹೋಗ್ತಾ ಇದ್ರೋ ಅವರಿಗೆಲ್ಲ ಶೇರ್ ಮಾಡಿ. ಸೊ ಚಾನಲ್ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಳಕ್ ಹೇಳಿ. ಸೊ ನೀವು ಹೆಂಗೆ ಸಪೋರ್ಟ್ ಮಾಡ್ತೀರಾ ಅದ್ರ ಮೇಲೆ ಸೊ ನಮಗೆ ಎಂಕರೇಜ್ಮೆಂಟ್ ಬರುತ್ತೆ. ಸೊ ವಿ ಕ್ಯಾನ್ ಡೂ ವಿಡಿಯೋಸ್. ಓಕೆ, ಸೊ ವಿಡಿಯೋ ಲೆಕ್ಚರಿಂಗ್ ಮಾಡೋದು ಸ್ವಲ್ಪ ಇಟ್ ಈಸ್ ಅ ಟೈಮ್ ಕನ್ಸ್ಯೂಮಿಂಗ್. ಓಕೆ, ಎಡಿಟಿಂಗ್ ಎಲ್ಲ ಮಾಡಬೇಕಾಗುತ್ತೆ, ಸರೌಂಡಿಂಗ್ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಅದನ್ನೆಲ್ಲ ನಲಿಫೈ ಮಾಡಿ ಮಾಡಬೇಕು. ಮತ್ತೆ ಸಾಫ್ಟ್ವೇರ್ಸ್ ಬೇಕಾಗುತ್ತೆ, ಲ್ಯಾಪ್ಟಾಪ್ ಬೇಕು. ಸೊ ಐ ಡೋಂಟ್ ಹ್ಯಾವ್ ಆಲ್ ಸಚ್ ಥಿಂಗ್ಸ್. ಓಕೆ, ಸ್ಪೆಸಿಫಿಕಲಿ ನನ್ನ ಹತ್ರ ಲ್ಯಾಪ್ಟಾಪ್ ಇಲ್ಲ. ಸೊ ಐ ಆಮ್ ಡೂಯಿಂಗ್ ವಿತ್ ವಿಲ್ ಗೋ ಟು ಸೈಬರ್ ಸೆಂಟರ್. ನನ್ನಲ್ಲಿ ಫ್ರೆಂಡ್ ಇದ್ದಾರೆ, ಅವ್ರ ಹತ್ರ ಇಂಟ್ರಾಕ್ಟ್ ಮಾಡಿಕೊಂಡು. ಸೊ ದಿಸ್ ಇಸ್ ದ ಪ್ರೋಸೆಸ್. ಓಕೆ, ಸಮ್ ಟೈಮ್ಸ್ ಡಿಲೇ ಆಗುತ್ತೆ ಪವರ್ ಫೇಲ್ಯೂರ್ ಆಗಿ. ಸೊ ನಮ್ಮ ಫ್ರೆಂಡ್ ಎಲ್ಲ ಊರಿಗೆ ಹೋಗ್ಬಿಟ್ಟಿದ್ದ ಒಂದು ವಾರ. ಸೊ ಅದರಿಂದ ಸ್ವಲ್ಪ ಡಿಲೇ ಆಯಿತು. ಸೊ ನಿಮ್ ಸಪೋರ್ಟ್ ನಮಗೆ ಅವಶ್ಯಕತೆ ಇದೆ. ಸೊ ಎಲ್ಲಾ ವಿಡಿಯೋಸ್ನ ತುಂಬಾ ಸೀರಿಯಸ್ ಆಗಿ ಒಂದ್ಸರಿ ಪ್ಲೇ ಮಾಡಿ ನೋಡಿ, ಪದೇ ಪದೇ ನೋಡಬೇಡಿ. ಓಕೆ, ನೀವೇನಾದ್ರು ಫಾರ್ವರ್ಡ್ ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಲ್ಲ. ಒಂದು ಕಂಪ್ಲೀಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಒಂದು ಕಂಪ್ಲೀಟ್ ವಿಡಿಯೋನ ನೋಡಿ. ಓಕೆ, ಸ್ಟಾರ್ಟಿಂಗ್ ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಇಂದ ಹಿಡಿದು ಎಂಡಿಂಗ್ ವರೆಗೂ ನೋಡಿ. ಓಕೆ, ಸೊ ಫಾರ್ವರ್ಡ್ ಮಾಡಬೇಡಿ. ಓಕೆ, ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿದ್ರೆ ದೆನ್ ನೀವು ಫಾರ್ವರ್ಡ್ ಮಾಡ್ಕೊಬಹುದು. ಏನು ಗೊತ್ತೇ ಇಲ್ಲ, ನಾನು ಬ್ಲಾಂಕ್ ಇದೀನಿ, ಈ ಟಾಪಿಕ್ ಬಗ್ಗೆ ನಂಗೆ ಏನು ಗೊತ್ತೇ ಇಲ್ಲ ಅಂದಾಗ ಫುಲ್ ಕಂಪ್ಲೀಟ್ ನೋಡಿ. ಓಕೆ, ಸೊ ಇದೇ ತರ ಸಪೋರ್ಟ್ ಮಾಡ್ತಾ ಇರಿ. ಮತ್ತೆ ಸಿಗೋಣ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ. ವೋಲ್ಟೇಜ್ ಅಂಡ್ ಕರೆಂಟ್ ರಿಲೇಷನ್ಸ್ ಆಫ್ ಆಲ್ ಟೈಪ್ಸ್ ಆಫ್ ಜನರೇಟರ್ಸ್, ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಮತ್ತೆ ಅದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಸಿಗೋಣ, ಬಾಯ್ ಬಾಯ್.